Alrighty, what we're gonna start off by is talking about rationalizing something. So if you look at this problem, you'll see that there is a square root in the denominator, right?
Mm-hmm.
So what rationalizing does is it gets rid of that root from the denominator, and then it's gonna throw it into the numerator. So how do we do this? The idea is pretty simple. What you do is you basically multiply whatever term you're given, in this case 3 over 4 root 5, with something called its conjugate. So now what's a conjugate? If you have something in this form, again, the numerator is irrelevant. It doesn't matter. The numerator can be anything. If you have something in this form or something in this form, what you do is you simply multiply it by this guy. So in this case, you'll just multiply it by root c over root c. Same thing here, root c over root c. This is called its conjugate. It's basically itself, if it's in this form. Where it gets slightly more difficult is if it's in this form. Now notice they're not being multiplied, these two terms, now they're being added or subtracted. In that case, you need the conjugate is not itself. In that case, the conjugate will be itself, but the sign in the middle will flip like this. So this would be the conjugate. Why do we do it this way? It's because this is a difference of squares in the denominator. And we know a plus b times a minus b is a squared minus b squared. So in this case, both of these terms will be squared in the denominator.
Mm-hmm.
And the square cancels out with the root, and then you have rationalized it. So it depends on what your conjugate is. Let's go one by one. Again, the idea is pretty straightforward. So in this case, what do we multiply this by on the top and on the bottom?
The root of 5.
The root of 5, that's it. So you have 3 root 5 on the top, 3 root 5 on the bottom. And now you're going to multiply the top with the top, you get 3 root 5. Multiply the bottom with the bottom, you get 4 times root 5 squared, okay, like that. And if you have a square and a square root together, they're inverses. They cancel each other out. So anytime you see a root with a square root, you just cancel them out. So your final answer will be 3 root 5 over 4 times 5, which is 20. And there you go, that's the final answer. So what we did was we got rid of the square root term in the denominator and we threw it into the numerator. Cool?
Mm-hmm.
That's what's called as rationalizing. Now this is the other case where things are not being multiplied, things are being added in the denominator. So now the conjugate is going to change slightly. What's the conjugate of root 6 plus root 3? If it's being added or something, what you do is it's going to be the same thing except the sign in the middle is going to flip. So it'll be root 6 minus root 3, like that. Then you have root 6 minus root 3, like that. Now let's go on the top. You have, again, this is in like a bracket. You can think of it that way. When you open this, you get 2 times root 6, which is 2 root 6, minus 2 times root 3, which will be 2 root 3, all over. Now look at this in the denominator. We have something in the form of a plus b times a minus b in the denominators. This is called a difference of squares. A plus b times a minus b is a squared minus b squared. So here, what do we get? If you do root 6 plus root 3 times root 6 minus root 3. If you use the difference of squares. So just take the first term, right? So just take the first term, look at this. The first term is a here is root 6. B here is root 3, right? B here is root 3. A plus b times a minus b becomes a squared minus b squared. So it'll become root 6 squared minus root 3 squared, like this.
And the square and the root cancel out.
Yeah, exactly. So you'll get 6 minus 3, like that. So the square roots are completely gone. And then you'll get 2 root 6 minus 2 root 3 over a 3. And that's going to be the final answer. Cool? It's not
Mm-hmm.
that difficult. Here's a question for you. Can I cancel out this root 3 with this 3 and leave over a root 3? Can I do that?
No.
No, you can't because of the minus sign, okay? In the middle right here. This, you cannot cancel anything here. This is it. You can't really go any further. I guess if you really wanted to, you could pull out the 2 and write it like this. That's the only thing you can do. There's nothing else you can do here. And that's it. Same idea here, just use a difference of squares. If there's something being added or subtracted, just use a difference of square. What's the conjugate? So again, if something is being added or subtracted, right, you want to use a difference of squares. The conjugate is going to be the same thing with a different sign. So it'll be this, like that. On the top, on the bottom, same thing on the top. And why can we do this? Why are we randomly multiplying by something? It's because this thing, in essence, is just a 1, because you can cancel out the entire thing on the top and the bottom. So you're multiplying by a 1. That's why you're allowed to do this.
Mm-hmm.
So on the top, it's easy. You get 10 root 6 minus 15. What do you get on the bottom? So again, you just want to use a squared minus b squared, right? Look at this. If I told you a was 2 root 6, b here is 3, what's a squared? It's going to be 2 root 6 squared. B squared is going to be 3 squared. So b squared is a 9. So a squared minus b squared. B squared is a 9. A squared, what's 2 root 6 squared? Is it 4 root 6?
It's 4 times 6.
It's 4 times 6. That's a 24. So then you have 10 root 6 minus 15 divided by 15. Can we cancel out the 15s?
No.
No, and that's it. That's as far as you can go, and that's the answer. And that's it. Nothing too complicated. It's just a squared minus b squared. I guess you could take out a 5 here. That's what they did. Like here, if you take out a 5, you're left with 2 root 6 minus 3, 15. And then you can cancel out the 15 with the 5, leaving a 3. So this would be the actual final answer. Now we've been doing it for the denominators, but we can also do it for the numerator. This is the next question, which asks us to rationalize the numerator. What's the conjugate?
It's the entire numerator.
So is it root 7 minus root 3, or is it root 7 plus root
Plus.
plus? Exactly. So now we're dealing with the numerator, so we don't care about the denominator. In the denominator, we have 2 root 7 plus root 3. What do we get in the numerator?
Seven minus 3.
Yeah, that's a 4. Can we cancel out this 2 with the 4, leaving a 2?
Yes.
Yes, and there you go. That's the final answer. That is it. It is 2 steps. Nothing complicated about this. Let's make things a little bit more difficult. But the idea is the same. Like, honestly, nothing changes. I will show you some tricks though. Like here it says rationalize the denominator. We don't care about the numerator. If it said rationalize the numerator, we'd multiply it by root 2 over root 2. This is for the numerator, but this one's asking us for the denominator. What's the conjugate?
It's the denominator, but you turn it to a plus sign.
Yeah, you turn it into a plus sign, and then you just use a difference of squares. So on the bottom, you'll get a 2, right? Do you see it?
Mm-hmm.
A squared is 20, b squared is 18, 20 minus 18 is a 2. What do you get on the top is a little bit more complicated. What's 8 root 2 times root 20? It'll be 8 root 40, like this. Okay? What you want to do is you want to multiply the root bits with the root bits, and there's no number on the outside, so you can just treat it as 1. So it's like doing 8 times 1, that's on the outside, and on the inside it's 2 times 20, 40. What is 8 root 2 times root 18?
It's 6.
Yes, it's 8 times 6, or it's 8 root 36, so this becomes 8 times 6, right? Like that.
Mm-hmm.
And 8 times 6 is what, 48?
Mm-hmm.
48. And this bit is a little bit tricky. Are you done with this? I mean, you've done what the question asked you, but can you reduce this any further? Because that's would be the best answer. And to understand that, you have to look more in detail with the root term that's we have left. We don't need to do this thus far because all the numbers were kind of small inside the root, but now we have root 40. What we can do with this number is we can reduce this. We can change this into a mixed radical. Right now it's just a radical with 40 inside of it. And the way to do this is to think about what's the biggest perfect square number. By perfect square number, I mean 2 squared 4, 3 squared 9, 16, 25. You got to think about it like this. What's the biggest perfect square number that 40 is divisible by? Does 16 go into 40? No, right? 16 doesn't go into 40. It goes into 32 and 48. You don't have to check for numbers that are less than half of this. So here, you don't have to check for 25. But 16, you start from here. 16 doesn't go into 40. All right, move on to the next smaller number. Does 9 go into 40?
No.
No. Does 4 go into 40?
Yes.
Yes, now look at the way how this is written. Root 40 becomes 4 times 10. 4 because that's the biggest perfect square number that's it's divisible by, and 10 because of how many times it goes into 40. And then I'm going to split the roots apart. So this becomes root 4 times root 10, which is still root 40. But now root 4 is a 2. See that? So root 40 is actually 2 root 10. So here we do 8 times 2 root 10. That's because that's what root 40 is. Plus 48 divided by 2. For the final step, you can pull out a 2 from everything. So you're left with 2 8 root 10 plus 24 over 2. Can we cancel out the 2's?
Yes.
Yes. And the final answer will be this. I guess if you really wanted to, you can take out a root 8, leaving you with something like this. So even though the question was answered here, you can go way beyond it. Especially if it's a multiple choice question, some of the options initially may not be there. So this is how you can turn a root or a radical into a mixed root. Now, instead of doing it with numbers, let's do it with letters or variables. So again, if it doesn't ask you, just look at where the root is. So all of these questions, we're going to be rationalizing the numerator. So for A, what's the conjugate?
Is it the numerator or denominator?
So there's no root in the denominator, so it's probably the numerator. So if it doesn't specify, just look at where the root is. In this case, it's going to be the numerator because that's where the root is. So what's going to be the conjugate?
Square root of a plus 2.
Yes. A plus 2, and then you do the same thing on the bottom. What do you get on top? Again, it's in the form of a minus b, a plus b, which is a difference of squares.
A minus 4.
Yeah. What about the bottom? There's going to be multiple terms in the bottom because none of them are really like terms. So for the bottom, you got to do a times root a, which is just a root a, and then do a times plus 2, which is 2a, and then do minus 4 times root a, which is minus 4 root a, and then finally minus 4 times 2 is minus 8, and there you go. That's what you'd get on the bottom. If you're multiplying two terms with two terms, there's no like terms, then you end up with 4 terms. And that's it for A. We've rationalized the numerator. By the way, this times this, I don't know how common this is, but you can write it as this. Square root of A is just A power a half. And using exponential rules, we have a1 times a, you need to add the exponents. So it becomes a to the power of 1 plus a half, which is 3 halves, or 1.5. So you can write this as a to the power 3 over 2. All right, let's move on. We'll just do one of these. Let's do B. What's the conjugate here? Again, we're trying to rationalize the numerator.
Root of x plus 4 plus 2.
Right, so it'll be root of x plus 4 plus 2. Root of x plus 4 plus 2. What do we get up top?
X plus 4 minus 4.
Yes, that's right. So you just get an x, and on the bottom you just have one term multiplying with two terms. So you'll just get this, and you're done. C is the exact same thing. For C, you would get x plus h minus x squared on the top, and on the bottom, again, if you multiplied it, you'll get something like this. That makes sense? Next thing we're going to talk about is the slope of the tangent line. All right, here we go. There's a lot of fancy words here, but we have talked about this a few weeks ago. tangent line is simply a line that kisses the original curve once. And the point where they touch, this point, is shared by both of these curves. It's shared by the tangent line. It's also shared by the original curve. And when it passes through that curve, it's going to be perpendicular. So over here, it'll look something like this. Over here, the slope will be negative. That is the tangent line, right? See this?
Mm-hmm.
So these are called tangent lines. And we can come up with the equation of a tangent line using the formula up there. Here, let me show you an example. So this is the question, that's the formula. And here's where things get a little bit tricky. So our function is f of x. The y is f of x, basically, and that's negative x squared plus 4x plus 1. It's asking you to find the slope of a tangent line. It depends on the x value. So step by step. Step 1, we're going to find f of a. In this case, a is your x value. A is just the x value. So we're going to find f of 3. So that'll be negative 3 squared plus 4 times 3 plus 1. That's negative 9 plus 12 plus 1. That's a 4. Yeah?
Mm-hmm.
Next, we're going to find this term, f of a plus h. So in this case, it'll be f of 3 plus h because a is 3. And this is where people find this kind of weird and difficult. See if you can figure this out. If f of x is this function here, what's f of 3 plus h? What you need to do is you need to replace those x's with what you have
3
in.
plus h.
So for the first one, it's going to be negative. X becomes 3 plus h, so it'll be negative 3 plus h squared. What's the next term?
Plus 4 times 3 plus h.
Yeah, plus 4 times 3 plus h and a 1. Now look at this. I'm going to show you something. A plus b squared is a squared plus 2ab plus b squared. If you remember this, you don't have to worry about spending an extra step trying to FOIL this. A is 3, right? Look at the formula. A plus b squared, it's in the right form. You get a squared, so you get 3 squared, which is a 9. Plus 2 times a times b, you get 2 times 3 times h, yeah? 2 times 3 is 6 times h. 6h is going to be your middle term. And then plus b squared. What's our last term here? Well, b is just h, right? A and b. So we did a squared 9, 2ab, so 2 times 3 times h, 6h. And then the last term is simply h squared, or b squared, so it'll be h squared. And then plus 4 times 3 is a 12. 4 times h is a h, 4h, sorry. And then finally we have 1, that's just 1. Now let's open this. So that'll be negative 9 plus, it should be minus 6h minus h squared plus 12 plus 4h plus 1. Any like terms? 12 plus 1 is 13, minus 9 is a 4. The highest power is negative h squared, and negative 6x plus 4h is minus 2h. And there you go. That's what f of 3 plus h is. Cool?
Mm-hmm.
So you want to open it up like this. And now finally, we're going to use the formula, which says the slope of the tangent line m, okay, is the limit as h approaches 0 of h in the denominator. H is 0. It's not technically 0, but it's we can treat it as 0 on a practical level. On the top, we have f of a plus h, so f of 3 plus h, which is negative h squared minus 2h plus 4 minus, okay, so this right here is your f of a plus h, minus f of a. What's our f of a? It's a 4. In other words, what's f of 3? We found it earlier. It's a 4. So that's your f of a divided by h. Do the 4's cancel out? Plus 4 and minus 4.
Yes.
So then you're left with limit as h approaches 0 of negative h squared minus 2h divided by h. Can we pull anything out in the numerator?
Negative 8.
Yeah, we can pull out an h or a negative h. So you're left with negative h minus 2, yeah, like that, all over h. Can we cancel out the h's?
Yes.
Yes. So here's the idea. We did this last time as well. Once the h's are gone, especially the 1 in the denominator, because this one is 0, once this h is gone, if you cancel this out, that's always going to be the goal, to cancel out this h in the denominator. Any other remaining h's is going to be 0, because that's what h is. So after the h in the bottom cancels out, you can't do this before you cancel this out, because then you'd be dividing by a 0. But once this is gone, it's fair play. Now this is going to be a 0. So therefore, your final answer is just 0 minus 2, which is negative 2. There you go. That's the slope of the tangent line. And that's the answer to part A. Did that make sense?
Mm-hmm.
Kind of complicated, but it is what it is. Part B says, determine the equation of the tangent line. And remember, tangent lines are just straight lines, linear lines. It needs to be in this form, y equals mx plus b. What we found here, this is the m value. So y equals negative 2x plus b. To answer the second question, to find the equation of the tangent, all we have to do from here on out is to find what this b is. Cool? Now the question is, how do you find the b value? How do you find the y-intercept of a linear line? You need to use a point that's already given, right? You see this? 3, 4. That's where our tangent line touches our curve. So this curve, we'll draw this in the next part, but it kind of looks like this. It's opening upside down, and when x is 3, so maybe right here, this is what we found, okay? The slope of this line is 2. Now we need to come up with the equation for that line. Notice where they touch, right? Where they touch, this point right here at 3, 4. When the x value is 3, the y value is 4 for both of those curves. That's a point they both share, okay? That's a point they both share. To find the b value, you need to use this point that we found over here. So replace your y with 4, replace your x with a 3, and then find your b value like this. So b is going to be 4 plus 6, it's going to be a 10. Therefore, the final answer is going to be negative 2x plus 10. And that's the answer to part B. Cool? Part C now is asking us to sketch this. It's easier said than done. How do you sketch this? To sketch a quadratic, you need 3 different things. You need the x-intercept, the y-intercept, the vertex. This is to sketch a quadratic. Do we know anything from the main equation? What do we know? We know that the y-intercept is 1, right? You can find the vertex by doing this. Vertex is negative b over 2a. That's the x value of the vertex. B value is 4, so it'll be -4 like that, okay? Over 2 times -1. So it'll be -4 over -2, it'll be 2. That's the x value of the vertex. How do you find the y value of the vertex if you know the x value? You simply plug it back in, right? This is called your h, the x value of the vertex. To find k, which is the y value, you're simply going to plug the x value back into the equation. So it'll be -2 squared plus 4 times 2 plus 1. That's 9 minus 4. That is a 5. So I'm just going to draw a rough sketch. You also need the x-intercepts, and unfortunately for this, you can't man it. You have to use the quadratic formula. Let me just do that really quickly. So the x-intercept is -b plus minus b squared minus 4 times a times c divided by 2a. So let me plug this in. That'll give us our x-intercepts. We have our vertex, we have our y-intercept, and we're basically done. 16 plus 20 divided by -2. So one of them is -1. -4 minus 16 plus 4 divided by -2. And the other one is like 4.24. So those are our x-intercepts. We know our y-intercept is a 1. And we know our vertex is 2, 5. Yeah, like that.
Mm-hmm.
So look at this. So this is what our quadratic will look like. That's our quadratic. And we know they both share a point of 3, 4 right there. And to sketch this, well, this is easy. It's just a linear line. So you start at the y-intercept of 10. And we know they're both going to pass through this point. So just connect it like that. Something like that. And that's going to be the sketch of the situation. So quadratics, we've done this hundreds of times. We've graphed this. The idea has always been the same. Find the x-intercept, y-intercept, and the vertex. To find the vertex, very simple formula. To find the x-intercepts, sometimes you have to use the quadratic formula, which isn't the end of the world. So here, this one's asking us to find the slope of the tangent. So again, it's the m value. Remember, to find the m value, this is the formula. Limit as h approaches 0. This is just a lot of jargon, I would say, because you just carry this forward until the very end, until you cancel out that h value. So not this one, don't worry too much about it. This just says when you cancel the h out, every other h is a 0. That's what it basically means, but you just have to carry it forward. And the formula is f of a plus h minus f of a divided by h, or a is the x value. So here, let's look at this question. What's our a value? Remember, a value is the x value. You look at the point that they've given you. What's the x value in this point?
2.
2. So your a is 2. A is just the x value. So step 1, find your f of a, which is f of 2. So it becomes 3 times 2 plus 6 over 2. So that's 6 plus 6, 12 over 2. That's a 6. Right?
Mm-hmm.
The next part is slightly more difficult. You need to find your f of a plus h. So if f of x is 3 times x plus 6 over x, what's f of 2 plus h?
3 times 2 plus h. And then 2 plus h in the denominator.
Yeah, like this. So you get 6 plus 3h plus 6 over 2 plus h, right?
Mm-hmm.
So that's what? 12 plus 3h over 2 plus h, like that. So that's our f of 2 plus h. Now we're just going to follow that formula. The slope is the limit as h approaches 0 of f of a plus h, which is a fraction, minus f of a, which was 6, all over h. So right now the h's are not canceling out. What do we do? What do we do anytime there's a fraction? You take the common denominator, right? Anytime there's a fraction, you're dealing with fractions, just take the common denominators, get rid of the fractions. So here what we're going to do is we're trying to do this first because it's in the numerator. What's the LCD? What's the common denominator?
2 plus h.
Yeah, so you want to multiply this guy with 2 plus h on the top and on the bottom, like that. Now they have the same denominators, you can combine them, right? It's the idea of fractions. As long as they have the same denominators, you can combine them. So you get 12 plus 3h. Now look at this. They both have a denominator of 2 plus h. And this minus sign applies to this entire term. So when you combine them, it'll be minus 6 times 2, 12, and minus 6 times h, minus 6h, like that. Do the 12s cancel out?
Yes.
Yes. So then you're left with this 3h minus 6h, which are like terms, so that's just negative 3h. So that's what it comes out to. Now here's a question. Does this h at the very bottom, does it go to level 2 or does it go to level 3? Sorry, level 1. Does it go all the way to the top or does it go to the denominator?
To the denominator.
To the denominator. So then you get limit as h approaches 0, okay? Negative 3h on the top, and that h at the very bottom goes on the second level, like this. Do the h cancels out? Can we cancel out the h's?
Yes.
Yes, and that's the main goal, right? To cancel out the h, because that h is a 0. We cannot divide by a 0, but we can definitely add or subtract or multiply by a 0. So once the h's cancel out, any other remaining h is going to become a 0. So you can ignore them. So plus 0, you can completely ignore this. Therefore, the slope of the tangent line is going to be negative 3 on the top over the 2 on the bottom. There you go. This is the slope of the tangent line. And you are done. Does that make sense?
Mm-hmm.
So this was not a polynomial, this was like a rational function, but you can find the slope of the tangent line of any function. It doesn't necessarily have to be polynomials. And this next question is why we're doing the rationalizing stuff, because you have to do that for this question. You'll see why in just a second. Again, the formula is limit as h approaches 0, f of a plus h minus f of a all over h. This is the formula for the slope of the tangent line. What's our a value here? A value is just the x value.
It's 9.
Correct. So then what's f of 9? Oh, that one's pretty simple. What's f of 9?
It's 3.
Yep. What's f of 9 plus h? You might just like we did last time, just replace the x that you have, right, with what you have in this bracket. So there's an x here. What's f of 9 plus h?
Square root of 9 plus h.
Yeah, like that. Now we're just gonna apply the formula. So it's gonna become limit as h approaches 0, right, like this, of f of a plus h, that's square root of 9 plus h, minus f of a, so that's a 3, all over in h. Now notice you can't really do anything with this. There's no denominators, there's no opening brackets, there's no nothing. So now you've hit a brick wall. So how do you simplify something like this? Notice that there is a root on the top, right?
Mhm.
So that should tell you what to do. You need to rationalize this to go any further. So we're trying to rationalize where the root is. In this case, it's the numerator. What's the
You
conjugate?
multiply with the root of 9 plus h plus 3.
Right, like that. And you did the exact same thing on the bottom as well. Plus h plus 3. So what do you get on the top?
9 plus h minus 9.
So 9 plus h minus 9, that's just an h. And on the bottom, you have h times that entire shebang of whatever this is. It's going to leave it on the outside. I'm not going to open that bracket. Do the h's cancel out?
Yes.
And that's the goal, right? The goal is to cancel out the h's. Now, any other h is a 0. So this h right here is a 0. So therefore, your slope, there's only a 1 remaining on the top. And on the bottom, you have 9 plus 0, square root, that's a 3. 3 plus 3 is a 6. And there you go. 1 over 6 is the final answer. That's the slope of the tangent line for this function. What does it mean? If you were to graph square root of x, it'll look something like this. And when the x value is 9, what's the y value? It's going to be a 3, right?
Mhm.
And at this point, if you try to draw a tangent line, it'll look something like this. It's perpendicular. The slope of this line, the rise over run of this line is 1 over 6. So for every 1 unit rise, it goes 6 units run. Okay, that's what we found. The slope of this tangent line that touches this point, 9, 3, and is perpendicular to the curve, the slope of that line is 1 over 6. Tangent line is also called the instantaneous rate of change, IROC, the instantaneous rate of change. What's the slope of the line at that instant? Is this making sense?
Mhm.
Here, we'll just do one of these. Determine the slope of a line that's perpendicular. So this is from grade 10 to the following. Do you remember how to do this one? They've given us a line, and we need to find the slope of a line that's perpendicular to this. First of all, what's the slope of this line that we're given? So notice first that it's not in the right form. It needs to be in the form of y equals mx plus b, yeah?
Mhm.
So we need to solve this equation for y. I only want y on one side and everything else on the other side. How do you solve this equation for y?
You add 11.
You add 11, then you subtract 13x, right?
Mm-hmm.
And then you divide by -7. Like that. So you get 13 over 7x minus 11 over 7. There you go. Now it's in the right form. So the slope of this line that we have right now is 13 over 7. So it's going like this way. And the question is, if something is perpendicular to this, what's the slope of this line? They're related somehow. The slopes are related. You need to do something with it. Do you remember what to do with it? You flip it upside down, okay?
Mm-hmm.
And then you change the sign. Flip it upside down and change the sign. So if the slope of this line is 13 over 7, the slope of this line is going to be 7 over 13, upside down, negative. There we go, and that's the answer to this question. It's negative 7 over 13. And that's it. Flip it upside down, change the sign to find a slope that's perpendicular. Before we do this, because now we're opening multiple brackets. By multiple brackets, I mean like cube, power 4. How do you open such brackets? So I told you about the idea for a plus b squared. Also a minus b squared. This will save you some time. It's a squared plus 2ab plus b squared. There's a minus, then you get a squared minus 2ab plus b squared. There's a minus, the first term becomes a negative. That's the only difference. This is for a square, which means there's only 2 terms inside, and the final terms you'll get 4 terms, but one of them is like terms, so you can add it up. So net total you get 3 terms. Now, how do you do this for higher powers? And the idea comes from Pascal's triangle. So we're gonna talk briefly about this Pascal's triangle. And then this is used to open big brackets, open higher power brackets. So if you have something cubed, something to the power of 4, something to the power of 6 or something, super useful. You could always FOIL it 6 different times, but it's not very efficient, very easy to make a mistake. So this way is the best, it's the quickest. So what is this? So it's kind of like a pyramid. At the very top, you have a 1, always. On the second level, you have 1 and 1. What does this imply? This implies, very first level, that's when you have a power of 0. So when you add anything, take to the power of 0, you get a 1, right? That's what the first level implies. The second level implies a plus b to the power of 1. So if you do a plus b to the power of 1, well, you get 1a and then you get 1b. And then you go to the next level. It's going to look like this. There's always going to be 1s in the beginning and at the end. And in the middle, you have to add up the previous line. So look at this. 1 to start off with, 1 to end with. But there's going to be a term in the middle. And the term in the middle is going to be the sum of the line above. So you get a 2. What does this imply? This implies a plus b squared. So for the first term, you have 1a squared. That's the coefficient. For the middle term, you have 2ab. That's the coefficient. For the last term, you have 1b squared. That's the coefficient. So Pascal's triangle gives you the coefficients and also gives you how many terms there are going to be. Let's keep building this. Again, for the next level, it's going to be to the power 3, which means you're going to have 4 terms. The number of terms is always plus 1. So if you're doing power 2, it's going to be 3 terms. Power 3, it's going to be 4 terms. We have our first term and our last term. That means in the middle, there are 2 more terms, okay?
Mm-hmm.
So how do you find those terms? So for the first one, you take this and this. Like that, 3. For the next one, you take this and this. What does that add up to?
3.
There we go. So those are the coefficients. So if you have a plus b cubed, okay, look at how this is going to work out. Your first term will have a coefficient of 1, and it'll be the first term that you have to the maximum power. So cube, cube. The next term will have a coefficient of a 3. And your first term, its power is going to drop by 1. Your second term, its power is going to go up by 1. All these exponents, the powers should always add up to the original exponent. So the powers will always add up to a 3. For the next term, your coefficient is also 3. Your first term, the power goes down by 1, so now it's a1. But your second term, the power will go up by 1 as well. So 1 goes down, the other goes up. So this went down, but b is going to go up. So that's why it's a 2. Does that add up to 3? Yes, it does. And for the last term, this is your coefficient. You take, so a now becomes a 0 because 1 power down, and b is going to become 3. And there we go. That's a plus b cubed. That's how you can open this bracket using Pascal's triangle. You're always going to get 1 and 1 as the coefficient in the beginning and at the end. And the first term will always be your first term to the maximum power. Your last term will always be your second term to the maximum power. But you can keep going. So the next one, why don't you tell me? This is for a plus b to the power of 4. What are the terms in there? So there should be 5 terms total. We have the beginning at the end, so that means there are 3 terms in the middle. What are the 3 numbers that go in the middle of this triangle?
4, 6, 4.
Yeah, 4, 6, 4. And then you can keep going, right? So it'll be 1, 5, 10, 10, 5, 1. For the next one, it'll be 1, 6, 15, 20, 15, 6, 1 for the next one, and so forth. Does that make sense?
Mm-hmm.
So why are we doing it this way? Let's answer a question right here, this one. So this question has asked us to clean this up, basically simplify this. There's a lot going on, but we have the Pascal's triangle. We should have no problem opening this bracket. Here, I'll help you. When you open this bracket, the coefficient of the first term is a 1. And then you take your first term, you take it to the maximum power, like that. So that's the first term of 3 plus h all power 4. For the second term, your coefficient is a 4. Then you take your first term, its power is going to drop down by 1. But your second term, its power is going to go up by 1. So now you introduce the h. So that's your second term. What's the third term?
The coefficient is 6.
Yeah. What's the power of 3?
2.
2. What's the power of h?
It's 2.
It's 2 as well. There we go. And the next term will be 4 times 3 power 1 times h cubed. And the last term is always 1 times the second term to the maximum power, 4. So what does this clean up to? 3 power 4 is 81. 3 power 3 is 27. Times 4 is 108. 9 times 6 is 54. H squared. 4 times 3 is 12h cubed. And plus h4. There we go. 3 plus h to the power of 4 square, everything to the power of 4 is this. And then we have minus 81, right?
Mm-hmm.
All over h. Do the 81s cancel out? Yes, they do. And this step is important. This is what you're going to be doing. If you have to cancel out the h, and the only way to cancel it out is if you pull out an h from the top. Like this. And now the h's cancel out. So that means any other remaining h is a 0, right? So this completely gone. This 12 times 0 squared is a 0. 0 cubed is also a 0. So therefore, the slope of your tangent line is simply what's left, 108. And there we go. And you are done with this. So that's how you can use Pascal's triangle to open like pesky little higher power terms. Very useful, especially if they ask you for 3 plus h to the power of 8 or something. You could 100% do this, but I think this is the dumb way of doing it. You can do it like 8 times, right? You can see.
Mm-hmm.
And then you're gonna get like 25 terms, and then you have to keep track of them, group up the like terms, yada yada. It's super inefficient. Pascal's triangle will give you the answer in a minute if you can build the triangle itself, which is not, again, not that difficult, right? It's just it's a pyramid basically. It's gonna be symmetrical. All right, so we can call it a day there for today.
Okay, thank you.
See ya.